morning, everyone. Good afternoon, actually. We are looking at limits, in particular, left limits, right limits, and overall limits. Now, let's look at what that would be equal to. Now, if I put this guy into a calculator, would you agree that it's probably going to have a vertical asymptote at 4? And it might be one of those. It might be one of those, or it might be a version of one of those, right? And we're being asked to find what the limit as x tends to 4 plus is. Is that a left limit or a right limit? Which of those two is that?
It's a right limit.
It's a right limit, right? So we are interested in what's happening, I'll do it in green, what is happening on this side as you approach 4. Now, you can do this by just plugging that into your graphic calculator. If this is the picture I see, won't the answer be plus infinity? If this is a picture I see, won't it be negative infinity? And if this is the one, we could do plus. But we can do it another way. What you can do is a numerical way. You're going to choose a value of x close to 4, but on the right-hand side. So how about 4.01, for example? And then you find the value of x plus 9 over x minus 4 at this value of x. So what I'm doing is I'm not even bothering to draw a picture of this. I'm just going to do this guy. And so what's that? 13.01 over 0.01, which I believe is 1,301. Would you agree that that is a very big positive number? And that would mean that we are looking at a plus infinity, because these questions want you to write down plus infinity or negative infinity, right? Because they are essentially vertical asymptotes. Now, in the next question, they tell you, and you could do, again, you could do it on your graphing calculator, but let's not. Let's do that guy. If I wanted to find what the left limit is, what value of x would I choose? Give me a value of x that would, numerically, that would help me answer this. So it's a left limit, 5 minus, whoops, 5 minus. What would we do?
4.9.
Yeah, or 4.99 or 4.999. Well, it depends how adventurous you want to be. I'm going to pretend it's 4.99. Now, if I put, I'm not doing this one, but if I put that in and I got the answer 179, then wouldn't that tell me plus infinity? But if I get negative 6,031, wouldn't that tell me it's negative infinity? You might say, well, how do you know it's infinity? Think about it. If you put 5 in the bottom, aren't you going to get something over 0? And something over 0 makes vertical asymptotes happen. So pick a number close to 5, but slightly less. If it was 5 plus, because it could have been, wouldn't I change the x value I would use in this situation? And in that case, I would probably pick something like 5.01, right? Something slightly on the big side. Are we good with what I've just done? How you can numerically find what the limits to left and right limits are by simply just picking a value of x close to 5 in big or close to 4 in big. If it's a 5 minus, then close to 5, but a little bit on the smaller side of 5. I'm now going to go over and show you the next question in using WebAssign, if I can. Darn it, I've got too many windows again. There we go. I'll have to shrink this one down to even have a fighting chance to see it. Here we go. Here is the function. It's a rational function, 4 over x cubed minus 1. It definitely has a problem at 1. And we are going to try and find this limit and this limit by using a table of values. Do you see that you've got a lots and lots and lots of values of x's? And for every single one of these values of x's, won't we evaluate this function? And we will write down the numbers that we get. And this will give us an idea of what the left limit is and what the right limit is. I'm making this up, but pretend I did that 0.9999 guy. And the answer I got was 10.0003. And suppose I did this 1.00 thing, and the answer I got was negative 5.001. Wouldn't you say the left limit was 10 and the right limit was negative 5? Now, more than likely, because it tends to be this, both of these end up being the same, right? Roughly. Wouldn't the left limit be 10 and the right limit also be 10? But in that case, wouldn't the overall limit also be 10? Right, so all three of them would match. Are we cool with how you would fill that table in and how you would generate it? So these numbers that go here are only a lead up to show you the pattern, to make say, yeah, I can see it's getting closer and closer to 10, and then this side the same. Now I'm going to go back into our whiteboard, and this time I'm going to show you how you can save yourself some work. I've showed you before, but I can show you more than once. How I would do that question. It was 4 over x cubed, so 4 divided by x cubed minus 1. Put a bracket around it. X cubed, take away 1, close brackets. Second table setup. Yeah, that'll do. Second table. Get rid of all the answers from the last time I used it. And 0.5, 0.9, 0.99, 0.999. I think that, right, I think there's 1, 2, 3, 4 nines, and finally 0.12345 nines. Interesting. Do you notice that these answers are getting bigger and bigger and bigger? And aren't they big and bigger and bigger and negative? So wouldn't that mean the left limit is negative infinity? If the numbers were getting closer and closer to 10, the left limit would be 10. But if the numbers get really, really big, doesn't that mean it's a version of infinity that's happening? So I didn't know that until I tried it. Oh, and then they give you a picture and you pick one of the pictures. So let's see if I can see that guy. Right, there's the function. I'm going to go to the window and I'm going to pick -4 to 6. And then I'm going to do zoom 0. And there should be a vertical asymptote going on. Oh, there it is. Can you see the vertical asymptote? Right at 1. Can you see as you come in from this side, it's really big and negative, so that's minus infinity. I bet you if you went this side, wouldn't it be plus infinity? So the left limit is negative infinity, the right limit is plus infinity, and the overall limit does not exist. Are we good? Any questions? Okay, yeah.
Just a quick question about the calculator. When you do table set, why are you are you starting at a certain point based on the x values that you're given in the problem?
Technically, I should have started at 1, but you don't need to. It's pretty versatile.
Oh,
because I put it on ask, it'll take any number.
Okay.
Did WebAssign? Did you join WebAssign? Okay. I can't hear you, so.
Yeah, I'm in.
Hey, okay. So you get 2 weeks not to worry about that part, right? Or if
Good,
you've
yeah.
already, you'll have to buy it eventually, but you need to wait until you get your money together, right?
Yep.
Well, is there any more questions before we move on to our last section for this week?
Yeah, could you go over how you did the graph again? Because I get an error when I try to do it.
Okay. So you do y equals, and the top number was 4. You do a divide, then you need a bracket. So put a bracket, x cubed, take away 1, close the brackets. Now make sure that is subtract 1, not negative 1. They look the same, but they're not. So use the grey button, which is subtraction, not that white button, which is negative. That might be the problem, okay? The window I chose was -4, so it is the white button because it's a negative, to 6. So you know, sometimes it's a subtract and sometimes it's a negative, depends on the context. And then I did zoom 0 and the picture appears.
Yeah, for some reason it gives me an invalid dimension error, but I'm not sure.
This is one of the frustrating things of not being in the class, because if I was in class, I'd just pick up and say, oh yeah, I can see what's going wrong, but I don't have that feature. I don't know what's wrong because I can't see what you've done.
Yeah.
I'm sorry,
well,
I can't help you, Mark.
I don't think it will be a problem because, like you said, they give you the pictures in the problem. So
okay, you can figure it out.
Yeah.
Right. So our next and final section that's due for this week is section 2.3, and it's going to be limits of a function. But we already covered pretty much the intro to this. So this is just a recap. If you want to find the limit of a function, you know, for example, the limit as x tends to 5, and we're talking about overall limits here, of something like x squared take away 25 over x minus 5. There are 3 methods that we can use. One of them I call brute force. That simply just means plug in 5. If you get an answer, that's the limit. The second one, well, there's 3 altogether. Can anybody remember the name of the second method that we used?
Factor and cancel.
Right. And I like that name because doesn't it basically tell you what you do? So you will factor and you will cancel, and then you plug in your number and you get the answer. I doubt very much if you could tell me the third one, because we haven't even shown you yet an example of it. But anybody got that third one?
Conjugate.
Yes, well done. So we are going to find limits of a function using what they say is limitless. So let's show you how simple some of these questions are going to be. This is a version of question 3. They want the overall limit as x tends to 8 of 5 take away 1/2 x. I tend to do brute force first, because if I can get the answer, why bother, you know, making life hard for myself? So in brute force, you just replace the x with 8. And if it works, right, if there's no mathematical algebraic issues with it, your answer is 1. Would you agree that's so simple, you might talk yourself out of doing it? Right, I just plugged in the number, I got an answer. That is brute force. That's what I mean by brute force. Let's find, and this is a version of question 4. Let's find the limit, oops, it's a t, as t tends to 4 of t squared take away t take away 12 all over t take away 4. If I did brute force, can you trust me? You get 0 over 0, right? Just trust it. It doesn't work, right? And 0 over 0 we call indeterminate for, right? Because it happens so often that we even have a name for it when it happens, right? So forget brute force. Looking at that question, doesn't it kind of look like it should be a factor and cancel because the quadratic factors, and it should, you know, it should work. So I'm going to do factoring. Anybody want to tell me how to factor or what the answer to t squared minus t take away 12 is?
T minus 4, t plus 3.
Now, this doesn't work all the time, but it works a lot of the time. Isn't there a very, very good chance that one of these two guys is going to be t minus 4? because you know the way the questions work. So if you get a really awkward, like imagine that was 120 when there's like tons of choices out there. Doesn't it make life easy if you know one of them's t-4? Because then you could figure out who the next one is. And the vast majority of the time, that's exactly what's going to happen. So I can now do the cancel. And our question now reduces to a much simpler, that guy. And that guy is just 4 add 3. That guy is 7. Me personally, I like factor and cancel because I like factoring, I guess. And there's something elegant about the way this worked out. You know, you factor it, you cancel it, and it turns into a dead easy question. Relatively speaking. I'm going to give you this one to try on your own. Brute force doesn't work. You get 0 over 0. Okay, you got 1 minute. Go for it. No pressure.
Three over 11.
Say again.
3/11.
Oh, you did it. I don't know is the short answer. You could be right. You're really fast. I haven't even got to thinking about it yet, but yeah, you could well be right. We'll give a few seconds. Right. Okay. But since you've got the answer, will you tell me what the top and the bottom factors are then? Start with the top.
I did x times x plus 3.
Correct.
And then the bottom, I did x plus 3 times x minus 8.
And you got those cancelling. Agree?
Yeah.
So it now turned into that fella. So far, so good. So -3. Oh, -3 over -11. You nailed it. You'll agree, those who got it finished, positive 3/11ths. Right. Let's say, for example, that is one of your test questions. Remember, this weekend you've got an online test. You don't know in the test whether you're correct or not. You know, in homework, you hit submit and it says green mark, and you say, great, I got it. But in the test, it won't tell you if you're right or wrong. There is a way that you can check that doesn't require too much time. Remember, that was the original question, right? All you do is pick a number close to -3, right? I'm going to pick -2.9, right? And then I just go and I go brackets. -2.9 squared, so it needs a bracket again. -2.9, close it, squared, plus 3 times in brackets, -2.9, close those brackets, then divide, start another bracket, a bracket for negative, lost my number, 2.9, squared, subtract 5 times -2.9, subtract 24, close the brackets, hit enter. Now, you're looking at 0.266, right? Let's find out what 3/11ths looks like. Would you agree that they're not identical, but would you agree that they're pretty close? That means you got the right answer. Now, if you want to be really sure, couldn't you do -2.999? And that would probably look almost identical by then. If you get it wrong, you tend to get it wrong in a major kind of way, right? So you do this and it's 42 and you got 0.27. Wouldn't that be a pretty fair indication I've done it wrong? And you get 5 shots in the online test. So if you know something's wrong, you know, because you've done this little check. So that's a way of checking. Can you try it again and say, oh, darn it, that's a plus, not a minus. I fixed it. Ah, now I like that answer. What you cannot do is you can't write 0.266605 and get anything. Because we want the exact answer, not a rounded off decimal. Because if you do that, can't you do every single question by just plugging them into the calculator? Right? You're not doing any math at all. So there's a check for you. A lot of these questions are similar, so let me do this one next. The limit as h tends to 0. H take away 3 squared, take away 9, all over h. This guy right now isn't quite ready to be worked on. I have to do a bit before. Okay, what do you think I do? If I seem to remember, we did one like this, whatever, a day ago. What do you do first in this expression?
You expand the
Right, so if you, exactly, you expand. If you did FOIL, can you trust me that you get that? And they cancel out. And now you've got that. And it's this form that's actually the one that I can use one of my methods on. Would you agree that factor and cancel, which tends to be your go-to method for most questions, it is the way to go here. So on the top, what can I factor out? On the numerator, what can I factor?
The H.
H.
Right. Can you remember us doing a question not unlike this one? Right, cancel. You're now going to find the limit of that, which is very easy to do. And so your answer is 6. Now, if that was an exam question, couldn't I pick a number like 0.01 and just evaluate that? And I'd probably get something like 5.98 and I'd say, yep, that looks pretty good. That looks to me like it's 6. I'm happy, I'll move on. Any questions? Are we feeling good about the algebra? In fact, in a lot of ways, isn't this much quicker than the number stuff with huge tables?
I just have a detail question.
Go.
Did you change the -6 to a +6?
Here, I did. You darn.
Okay.
I did. Well caught. Don't know why I did that. Just being careless. Do you think it's time we had a look at a question that was a conjugate method? Because we've never shown you one yet. Okay. Now, I'll probably do some more factor and cancels, but let's show you a conjugate method because I think you've waited too long for it. So here's an example of one. And it's a limit as x tends to 4 of 4 take away x over 2 take away the square root of x. Now, you might say, how do I know, or when do I know to use the conjugate method? And the answer is, if there's a square root, and we're talking about square root with x's in it, or square root of x plus 1, or the square root of 2x, right, a square root with an x. And the conjugate method is really magical, right? There's no way in the world I'm actually going to factor that guy. Would you agree? Just doesn't factor. And can you trust me, if you plug in 4, you get 0 over 0. So I guess you could say, if it isn't the first two methods, I guess it has to be the conjugate method because there's nothing left, right? But I prefer you to see it if you see a square root. Now, there's a rule in mathematics that says if you've got a fraction and you multiply it by 1, you don't change its value. But we're going to multiply it by a special version of 1. 1 could be just 1 over 1, but couldn't 1 be 7 over 7 or x over x or anything you like over the same anything you like? The special version of 1 that we're going to use is called the conjugate. That's why it's given that name. This term here is called the conjugate. Now look how it works. It's the same as the guy that's got the square root, but the negative is turned into a positive. And you might think, well, that's just made the question worse, not better. But it actually helps a lot. It actually makes things come out really nicely. So I'm just going to write these two guys like that. And do not FOIL these two guys out. But I am going to FOIL these two together. So I guess I should do that on the side somewhere. So do not do it to this one, but do it to the guy and his conjugate. Sometimes the conjugate guy is on the top. Sometimes the conjugate guy with his original is on the bottom, as it is here. So I'm going to do 2, take away the square root of x, multiply by 2, add the square root of x. And here is FOIL. The F, 2 times 2 is 4. Then you do O, which is the outside. And the outside is 2 times plus root x, so that's 2 root x. And then you do the I, which is the inside. And negative root x times positive 2 is negative 2 root x. And then you finish with the last, this guy times this. And I'll write this down. That guy times that guy, right? What does negative the square root of x times the square root of x get you? What does that simple? I totally agree. Now, do you notice that the middle two terms kill each other off, and you are now left with 4 minus x? Oh, look at that for magic. There's the original question. I multiplied it by this special version of 1 called the conjugate. I left the top 2 alone, but I did FOIL the bottom, and it became this. What's going to happen in my next line of working then? What am I going to do?
Cancel out the 4 minus.
Agreed. And isn't that just going to leave me with that guy? But that guy is just 2 plus the square root of 4, which is 2 plus 2, so the answer is 4. Oh, come on, is that not cool? Right? You took something that is ridiculously ugly, right? It's a fraction with a square root in it. There's no way in the world that's pretty, right? Then we multiplied it by the special version of 1 that turned it into this, which almost by a miracle, but actually it's not, you're going to get a cancel, because you always get a cancel when you do the conjugate method as well. And whatever's left, you can just evaluate. Okay, let's do another conjugate one. Let's do the limit as h tends to 0 of 4 plus h, take away 2 over h. And I'll put a little bracket around it again now. Do you see that there's a square root involved? When you see a square root, shouldn't you be thinking conjugate method, right? Square root, conjugate method. Which means I'm now going to have to multiply by a special version of 1 called the conjugate. What do I write here? There's the original. What does its conjugate look like?
The same, but with plus.
That's a good way of saying it, actually. the same with a plus. Now, in this question, I'm just going to leave the bottom alone. But won't I FOIL the top? And if you do the square root of 4 plus h take away 2, multiplied by the square root of 4 plus h add 2, something really nice is going to happen. So I'm going to do it over here. And if I do the f first, what does the square root of 4 plus h times another square root of 4 plus h get you?
4 plus h.
Yeah. Then if I do the outside, the square root multiplied by a plus 2 just gets me 2 square roots. If I do the inside, a negative 2 times a square root just gets me negative 2 square roots. And if I do the last one, a negative 2 times a positive 2 gets me negative 4. Now, how about this for some carnage? Won't this guy kill off that guy? Anybody else get killed off here?
Yeah, the 4.
In fact, isn't the only thing left alive was an H? Have you noticed that my description of simplification is very violent? Things get killed off. I think it's because of my Scottish ancestry. We're kind of violent people at the best of times. So I think of these things as almost little battles where things are killing each other here, there, and everywhere. And in this case here, hasn't something really, really nice happened, as it should? Can't we cancel the H's? Now be very careful about the next line. I am deliberately doing a mistake here. That is not correct.
It's to be a 1 on top.
Yeah. You know, when you cancel something out, there's a kind of little 1 that's left behind. And in this case, isn't that much more important than the previous question? Because 1 over something's not the same as the something. Would you agree? So now I can put in 0. It's going to be the square root of 4 plus 0 add 2, square root of 2 add 2, and the answer, hey, we got a quarter. Do you like the conjugate method? So? Okay, I'm going to give you one to try then. What shall I pick? It's always hard to pick things like this, isn't it? Double check that all works. Okay. You got 2 minutes. Find that one. I'm going to write it again a little bit neater. Last few seconds. Right, I need to multiply by the special version of one called the conjugate. Any volunteers for what the conjugate would be?
Rad x plus 13 plus 4.
Now, if you FOIL this guy out, you basically get an x plus 13, take away 4 root x's, add 4 root x's, take away 16. But after all that hard work and a lot of dying, don't you get an x minus 3 on the top? And on the bottom, you've got an x minus 3 followed by that guy, right? And like magic, remember to leave the 1 behind. You are now looking at that guy. And since I want to go on and do one more question, at least one more, doesn't that eventually get you square root of 16, which is 4, and 4 add 4 get you 8? If you feel comfortable about that, it went well. If you did it correctly, you might, if you ran out of time, that's how you would have finished. We're good, guys, so far? So I'm now going to show you some questions still on the conjugate method. I'm focusing more today on the conjugate method. Tomorrow I'll probably do more in the factor and cancel again. I think factor and cancel for the most part is pretty obvious, right? They all look the same. You kind of do the same thing. But here are two, well, definitely one, and if I've got time, two issues with that can happen. So this is a version of question 12. Looks pretty standard. Conjugate is the same guys, but with a plus. Okay, which of the two in the top or the 2 in the bottom, which of those 2 do I FOIL? Because the other ones you leave alone.
Two on the bottom.
Right. Don't you always do the original guy and its conjugate, right? So if you do the 2 guys on the bottom, can you trust me that you get x minus 2? I mean, you do the foiling and that, but for time, can you just trust me you get x minus 2? And on the top, you get 2 minus x, and you get this. And this is the first time this has happened. Hey, those 2 guys are meant to cancel. That's the way this works. They're meant to cancel. But 2 minus x isn't the same thing as x minus 2, agreed? Right? It should be x minus 2 top, x minus 2 in the bottom, right? That's what you'd expect to see. And many of the times that's exactly what you'll see. But this actually can be cancelled. I don't know when the last time you saw this, but I know that you definitely did see it. You are allowed to cancel 2 minus x and x minus 2, right? They do cancel each other out. They don't leave behind a 1. What do they leave behind? If x minus 2 cancels 2 minus x, what do you get out? Typically you get 1, but not this time.
You just get 0? Or
Oh, not
Negative
0. But you're thinking is good.
Negative
No.
1?
Yes, you get negative
Negative
1.
one. Yeah.
Yeah, can you remember 3 minus x cancelling x minus 3? You remember those weird cancelling things that you may have done in 94, is it? Early 99? Can't remember one of those 2. So you get a negative 1. So I'm going to rewrite that because I put a line I didn't need. So you would end up, after you'd cancelled, with that guy. And negative the whole thing. So it's negative that fella plus that guy, 2 add 2 gets you 4. So I guess the answer is negative 4.
Wouldn't pulling out the -1 at on the top, wouldn't that change the, oh, okay, never mind. Sorry.
Right, no, I like your thinking because I think I know what you're doing here, right? See that 2 minus x? Forget about the square root. That's a distraction, right? And on the bottom, we've got x minus 2. Couldn't you pull out a -1 as a common factor? And if you did that, wouldn't you get -2 plus x? Wouldn't it be better to call it x minus 2? And can you see why when you cancel now, there's a negative left behind? That's kind of the proof behind why that works. So if you ever get a question where it's something, take away something on the top, and the same two guys but subtracted on the bottom, right? That kind of general thing, you are allowed to cancel. We just remember that the answer is negative. Boom, you're good. Things got ahead of me, so I only have time to do one. So could you make sure you do your last name? If there's anybody got problems with getting into the class from the wait list, I'm going to hang about for a couple of minutes for you, or WebAssign issues, I'll hang about for that. So once you've got your last name down, it's a bye-bye, and I will see you tomorrow, where we get to do some more fun conjugates and factor and cancel, and some other weirder ones. I like the weird ones because you have to think harder on those ones.